All right, so on to 3.3 part 2, we're going to talk about the condensing the logarithmic expression. So yesterday, or part 1, we talked about expanding and what those 3 basic properties were. Today we're going to talk about condense. So just as a warm-up here really quick, I want to see what you remember from yesterday. So let's see if you can write out the other half of these 3 properties. So go ahead once I have these written down. Go ahead and see if you can write what the other half of this property would be. So go ahead, pause the video, see if you can come up with what those 3 are. All right, so here are those 3 properties. The log of the product, property number 1, is the sum of the 2 logs. Property number 2, the log of the quotient is the difference of the 2 logs. And then log of power to a power is the product of those 2 logs. So it's basically, again, those same 3 exponent properties that we always use, because remember, logs are exponents, so they follow those same rules. All right, so today we're going to talk about condense for part 2 here. Condense means to rewrite into a single log expression. So remember my analogy of the puzzles in part 1. This is where you have all the puzzle pieces. They are all separate, and you're going to put them together into one picture. You're going to make the puzzle. So all these separate pieces you need to reassemble and make the picture. So we're going the other way. So again, when you think about like solving an equation, something like that, you might be trying to put things together. This would be that kind of a thing. So it's going to say condense. It might say rewrite as a single log. Both of those things mean the same thing. We're going to put pieces together. So remember yesterday how we talked about PEMDAS? That's helpful for us when we condense as well. Think about order of operations and what would you do if you're actually going to do this arithmetic if you could, like if you knew what x was. That's kind of what we would want to be doing when we put it back together. So the first things that you would do, think of what you see. I see a 3 times a log and then a plus a 4 times a log. Okay, so think about order of operations. You would probably do that multiplying stuff first, and then you would do the addition. Okay, what does that translate to into logs? The multiply is the power to a power property, and the add is the product property. So when we're going to put them back together, we're going to deal with the things that were the exponents first, or the powers, and then we're going to deal with the things that were added, which was the product. So we're going to do that in that same order. So think of order of operations to put it back together. So where else can the 3 go? Well, it can be an exponent. So this would be log of x cubed. That would be doing this. I'll just number these here again. So we had, and that's doing that third property, but we're starting with this. We're starting with the green, and we're condensing it and putting it back as the power property. Same thing for the 4 then. That 4 can go back up as an exponent. Notice the argument is that whole thing x minus 1, so that whole thing to the 4th. And again, that's that third property. All right, now to write it as a single log, I'm going to have to address the addition, which is the next thing you do in order of operations. That's the product property. Let's go back to our properties. That's property number 1. But again, we're starting with the green, and we're going back to the blue. So I have the sum of 2 logs with the same base, and I can put them together as the log of the product, so they're multiplication. So this would be log of, my first argument is x cubed, and then times, my second argument is x minus 1 to the 4th. I wrote it as a single log. That's the whole idea of condensing, putting it back together. So think about order of operations as we do that. It really does help. All right, we're going to practice several more. So this will be super similar. See if you can put this one back together. What would this look like as you do that? So think of order of operations. What would you do? Pause the video and then see how it compares to what I'm going to do. All right, so order of operations, I would multiply first by that 3rd and the 5, and then I would deal with the addition. Okay, what that means in my my lingo for logs here, it's the power or exponent properties. So I'm going to deal with the power first, and then I'm going to deal with the product property, which is the add. So just thinking about what it means in that world. All right, so my powers, my 1/3 can come up top here. So it's x to the 1/3, that's power to a power. My 5 can come up to this argument, so log of x minus 3 to the 5th. Okay, Now, a couple things to keep in mind. How else can you write the 1/3 power? When we go back to condensing, we can put it back as its original, like what makes sense to people. What is x to the 1/3 in radical form? Well, remember the bottom number is always your root, so cube root of x to the first. So I'm going to go ahead and think of it as log of the cube root of x again. Sometimes that's easier for people to look at. When we go back into this condensed version, we understand what that function means. All right, so we dealt with multiply the powers. Now we're going to deal with this addition, that plus sign in between. What does adding mean? That's the product. We're going back again to this property number 1. Again, we're starting at the green. I have the sum of two things. I'm going to rewrite it as the product of those two arguments. So that would be the log of the cube root of x times product x minus 3 to the 5th, and I've written it as a single log. The more complicated the expression, the harder this is to do, but it's kind of like a puzzle again. You're taking the separate pieces and putting them back together, and some people really enjoy these once they get the properties down. They're kind of fun to break apart. All right, I want you to give this one a try. I want you to see what happens. This is a little bit different in where the 1/5 is, and if you think of order of operations, people can deal with this one differently. So give it a whirl and then kind of check back in with the video and see what's happening. So here's how some people view it. They would say, okay, I have grouping symbols, so I would start with what's inside first. I would deal with the addition first, and then deal with the multiplication. Okay, that's how a lot of people would look at this because there's grouping symbols. So dealing with the addition first means the product property, and then the multiply by the 5th would be the power property. So I'm going to address it that way and talk about what that would look like. So that would be a 1/5. And then how would I deal with the sum? Well, that is the sum of two logs is the log of the product. So that would be x times x minus 2. Okay, so it would be that product. All right, and so I dealt with the add, right, which is the product property. And then where else can the 1/5 go? Well, it comes up as the exponent of that argument. So I'm dealing with the power of the multiply. So that would be natural log of x times x minus 2 to the 1/5 power. Okay, now remember what 1/5 power means. That's the same as the 5th root of that entire argument x times x minus 2. So you can even go as far as saying distribute that through x squared minus 2x. If that's easier for you to deal with, totally fine. So this was dealing with the addition first because it's inside the grouping symbol. So add means the product property, so I multiplied. And then dealing with that number out front as the multiplication, that's the power property, and I brought it up top. To the entire argument though, right? That entire thing would be under that 5th root or radical. Now let's take a look at it from a completely different perspective. Some people look at this and say, well, can't I just distribute the 1/5 through? So couldn't it be the same as 1/5 times the natural log of x plus 1/5 times the natural log of x minus 2? Absolutely, you could distribute first. So then you'd be dealing with, in this order of operations, you would be dealing with the multiplies again. So the 1/5 times the 1/5 times, which is the powers. And then you would be dealing with the add second, which would be that product property. Let's see if you get the same answer. All right, so we're going to move these up. These are our power properties. So natural log of x to the 1/5 plus the natural log of x minus 2 to the 1/5. Remember what 1/5 powers are. Those are the 5th roots. So you can deal with that now or after, kind of have your choice here. Let's go ahead and deal with the add. Then we did the multiply. Let's deal with the add, which is the product. So that would be the natural log of x to the 1/5 times x minus 2 to the 1/5, which means the natural log of the 5th root of that product. And you're going to end up with exactly the same thing as we had. And again, if you want to multiply it out, you're welcome to do that. as well. So it's kind of cool. There really are different approaches to these depending on what order of operations you want to do as far as moving forward for condensing. Kind of a cool situation. All right, let's take a look at the last one. I want you to go ahead and pause the video again. And again, you're going to have options. There's different ways to approach this depending on how you do your order of operations. So let's see what you come up with, and then we'll take a look and compare. All right, so if we follow the regular order of operations and don't distribute that 2 through first, we're going to have to deal with inside the grouping. So inside, we're going to have to deal with the multiply, and then we're going to have to deal with the subtract. All right, so let's see if we can deal with those. We'd have the 2 on the outside. It would be log of x plus 3 minus the log of x minus 2 squared. So we're bringing that 2 up top. Okay, now still inside the grouping symbols, I would deal with the subtraction next. So log of the difference of 2 logs. So I'm going to go back to my properties here. This is property number 2, but again, I'm starting with the green. The difference of 2 logs is the log of the quotient. So let's go back to that. So that would be 2. It's going to be the log of first argument, x plus 3, divided by the second argument, which is x minus 2 squared. Okay, so it's the log of the quotient. Now those arguments, they stick together, they're binomials, nothing I can do with that. Then, order of operations, I did everything inside the grouping. Now I deal with that 2. I go back to the power property. So it's going to come up, and it's going to be for this entire argument, it's going to be its exponent. So it's log of that entire fraction. So x plus 3 over x minus 2 squared, that whole thing is going to be raised to the second power. So let's be careful how we can deal with that then. Remember, when you take a fraction and you take everything inside to the second power, that means it would be x plus 3 squared in the numerator, and then x minus 2 to the what? Well, 2 to the second, that would be to the 4th power. So we'd have that argument. So it works super well. So that was just taking it face value just the way it is. But again, some people might start, and you can certainly do this, with distributing the 2 through. So it'd be 2 times the log of x plus 3 minus 4 times the log of x minus 2. This might be an easier approach for you. You can see what makes more sense. In this situation, we've gotten rid of those big grouping symbols, so we follow normal of order of operations. We deal with the multiplies first, so those powers are going to come up top. Power properties, so the log of x plus 3 squared minus the log of x minus 2 to the 4th. And then I can deal with the subtraction. The difference of 2 logs is the log of the quotient. So x plus 3 to the 2nd divided by x minus 2 to the 4th. Now, if I compare these two, I kind of think the second way is a little bit easier, getting rid of those big grouping symbols first to do that condensing. So it really is a matter of kind of perspective and what's easier for you. But that's what condense means, writing it as a single log, taking all those separate little pieces and putting them back together.